This is the second half of a video on polynomial operations. We will be multiplying polynomials, factoring out GCF, factoring by the difference of squares, etc. However, if you have not watched the first video, you should go ahead and watch that now. I'll put a pop-up link right about here. Here's number 9. Which of these polynomials can be factored using the difference of squares pattern? Okay, so this time we're looking for ones that can be factored. All right, last time we were looking for ones that were prime. Right, we're looking for ones that couldn't be factored. So you got to switch your brain. We're looking for the ones that can be factored, and specifically, they have to be factored by the difference of squares pattern. So GCF doesn't count. Well, we can eliminate this one right away because it has a big old plus sign on it. It has to be the difference of two squares. It has to be a subtraction. Okay, so forget about the last one. What about the rest? Okay, maybe I'll just leave this with a big old X to it for now. What about the first one? This is going to be a no because of the 9. The 9 is the problem. I know what you're thinking. It seems like this would be okay because 9 is a perfect square. 9 is 3 times 3. Everything else is a perfect square. But this is no good. This actually has to be an even number. Any even number would have been fine. And the problem is this. If I try to factor this using the difference of squares pattern, I would have 9x. Say if I try to do what you're thinking, and I try to factor this as with a 3. So I would try to do 9x to the third power plus 4 and 9x to the third power minus 4. This would be maybe a common mistake. The problem is when you multiply x to the third power times x to the third power, that does not give you x to the 9th power. All right, we've learned earlier that when you do x to the third power times x to the third power, you add these exponents. So this will actually give you x to the 6th power. So this will not give you what you want. So the only way for this to work is if this exponent is an even number. Any even number would have been fine. For example, what if this had been, let's say, instead of a 9, imagine this was an 8. All right, it was x to the 8th power. Then this would work out because then I could factor this as 9x to the 4th power plus 4 and then 9x to the 4th power minus 4. All right, because x to the 4th power times x to the 4th power does give you x to the 8th power because you add the exponents. You don't multiply them. So any even power would have worked. But it wasn't an even power. It was an odd power. So this is a no, unfactorable. Okay, what about this one? All right, this one checks all the boxes. We have the difference. Okay, so that's good. We have a perfect square here. The 4 is a perfect square. The 9 is a perfect square. And unlike the previous problem, we have an even number right here. And that's what we needed. So specifically, this would factor as 2x to the 4th power plus 3 times 2x to the 4th power minus 3. So this is factorable. So we're supposed to circle all the ones that can be factored. So let's circle this one. And lastly, this one. This can also be factored. X squared it has that even power we were looking for. And the number 1 is a perfect square, okay? Because 1 times 1 gives you 1. So we can factor this using the pattern. This would just be x plus 1 times x minus 1. All right, so you should have circled the 2 in the middle. All right, we're factoring out the GCF again. Okay, let's be very careful. When you have larger numbers like this, the 45 and the 15, sometimes you can accidentally pull out a number that is too small. For example, at a glance, you might notice that 45 and 15 are both divisible by 5. So you might jump to the conclusion that 5 is going to be part of the GCF. That's a really bad 5. But let's be more careful than that. We have these two numbers, 45 and 15. I have taught you to focus on the smaller number first. Focus on the 15. What are all of the numbers that divide evenly into 15? 3 goes evenly into 15. 5 goes into 15. But don't forget about 15 itself. Okay, 15 also goes into 15 one time. So these are all of the numbers that divide evenly into 15. Okay, now, do these numbers divide into 45? Let me take out my calculator. 45 divided by 3. Notice that 3 does go into 45. What about the number 5? Well, obviously, 45 is divisible by 5. We could tell that because there's a 5 on the end of it. So anything that ends in 5 is divisible by 5. So that means that so far, the 5 is winning because we want the greatest common factor. The bigger number wins. But what about the 15? Okay, you might have noticed this earlier if you were paying careful attention when I divided by 3. But yes, 45 is divisible by 15. All right, 15 goes into 45 3 times. That means that 5 is not going to be part of the greatest common factor. 15 wins. You want the biggest number you can. And in this case, the greatest number is 15. Okay, so common mistake is putting a 5 right here. It should be a 15. The variable part is easier because you just go with the smallest amount of variables that you see. So look at the variable a. The first term has 3 of them. The second term has 2 of them. What's the smaller amount that I just said? 2 of them. So I'm going to put 2 a's in the GCF. What about the b's? The first term has 5, the second term has 3. So I go with 3 because that's the lesser amount. The variable part is easy. To figure out what goes inside the parentheses, we should divide by the GCF. So I am going to divide each term by 15 a squared b to the third power. Okay, 15 a squared b to the third power. 45 divided by 15 is 3. All right, we kind of saw that on the calculator a moment ago. A to the third power divided by a squared is a. Okay, and just once again, focus on this. I'm doing a to the third power divided by a squared. One way to think about it is subtraction. 3 minus 2 is 1. So that's why it's just a. Another way to think about it is that a to the third power is really a times a times a. And a squared is a times a. So the 2 a's in the top cancel out 2 a's in the bottom. leaving behind a single a. That's the other way to think about it. What about the b's? I have b to the 5th power divided by b to the 3rd power. That's going to be b squared. 5 minus 3 is 2. The last term, well, notice that the numerator and denominator are exactly the same thing. Everything cancels out, but I'm not going to leave nothing. When you have something divided by itself, that equals 1. So don't forget the 1. Very important. All right, so this is the answer. Okay, factor this polynomial using the difference of squares pattern. All right, so this is what we talked about before. 49 is 7 times 7. X to the 8th power is going to factor as x to the 4th power times x to the 4th power. When we do the difference of squares, we have a plus and a minus. And then 25 is 5 times 5. So that's it. Difference of squares is super easy. Okay. Factor each polynomial completely using GCF, difference of squares, or both. Watch out for the or both part. So, okay, is there a GCF on this problem? Yes. Okay, so it might not jump out at you, but both of these are divisible by 3. There is a GCF of 3 here. Okay, both of these can be divided by 3. So I can rewrite this as 3 times, and then whatever's left behind. 27 divided by 3 is 9. Okay, and then I just have the x squared. 75 divided by 3 is 25. Okay, you use your calculator if you need to, but 3/4 makes 75 cents. A common mistake is to put this as the final answer, but you have to watch out for the difference of squares part. We did the GCF, but what about the difference of squares? 9x squared minus 25 is the difference of squares. So I'm going to keep the 3, all right? Don't forget the GCF. That's a permanent part of the answer. But I'm going to take the 9x squared minus 25 and do the difference of squares pattern. So this will be 3x plus 5 times 3x minus 5. All right, number 13. There is definitely a GCF here. Let's look at the 16. What are all of the things that will divide evenly into 16? 2, 4, 8, and 16 itself. All right, these are all numbers that divide evenly into 16. Which of these divide evenly into 100? 2 goes into 100. So far, so good. 4 goes into 125 times. That means that so far, 4 is winning. Is 100 divisible by 8? Let's see, 100 divided by 8. No. Is 100 divisible by 16? No. All right, that means that 4 is the greatest common factor in terms of the numerical part. Okay, so I'm going to definitely have a 4 in my GCF. Now, how about the variable part? Are there x's in both terms? No. So there will be no x in the GCF. Are there y's in both terms? Yes. What's the smaller amount of y's? The second term has 2 y's. That's the smaller amount. So that means 4y squared is my GCF. To figure out what goes inside the parentheses, I need to divide by that GCF. All right, 16 divided by 4 is 4. The x to the 6th power will not be affected. Okay, now y to the 4th power divided by y squared is y squared. Okay, I might need more space. 100 divided by 4 is 25. And then y squared divided by y squared, well, those simply cancel each other out. Okay, and this is the final answer because we cannot do the difference of two squares pattern. This is addition, so you can't do the difference of squares. All right, how about number 14? Okay, I'm looking at the 10, and 10 is divisible by 2 and 5, but don't forget that it is divisible by 10 itself. Well, 90 is divisible by 2 and 5 as well, but 90 is divisible by 10 itself. So 10 wins. So when I do my GCF, I'm definitely going to have 10 as part of my common factor. What about variables? Do both terms have x's? No. Do both terms have y's? Yes. They both have y to the 6th power, so that's definitely going to be the GCF for the y part. What is going to be left behind? To figure that out, we need to divide by the GCF. So I'm going to divide everything by 10 y to the 6th power. Divide by the GCF. So let's see. The 10s cancel each other out. And then we have the x squared. And then the y to the 6th power, they cancel each other out. So it's just x squared. And then minus. Okay, now I have 90 divided by 10, that's 9. And then the y to the 6th power, they cancel each other out. So we have this. So a common mistake is to put this as the final answer. But once again, no, no, no. This is the difference of squares, obviously. So I'm going to definitely include my 10y to the 6th power, my GCF. But I'm going to take the x squared minus 9 and factor that further using the difference of squares pattern. So this will be x plus 3 times x minus 3. Okay, the shape shown here is a rectangle. Use it to answer the next two questions. Give your answer in standard form. Find an expression for the perimeter of the rectangle. The perimeter of the rectangle is just the sum of all the sides. So, of course, this side right here, this length, is also 3x squared minus 7x, all right? These two sides are the same. And this height on the right is x minus 2, just like it is on the left. So the perimeter will be the sum of all of these. So it will be 3x squared minus 7x plus 3x squared minus 7x, all right? That's those two. And then now the heights, it'll be plus x minus 2 plus x minus 2. All right, I'm adding up all four sides. So it's just a matter of combining like terms. I've got 3x squared and 3x squared. All right, those are the only squared terms. So that's going to make 6x squared. Notice that when you are adding with variables, you're only adding the coefficient in the front. The exponent does not change. All right, this is not going to be x to the 4th power, for example. That only happens when you multiply. Okay, so what's next? X terms. I have 7x, well, negative 7x. I have another negative 7x. I have a positive x and another positive x. All four of these are like terms. Negative 7 plus negative 7, that's negative 14. But then I have plus 1. So look, it's kind of like this. The negative 7 and the negative 7, that makes negative 14x. The x plus x, that's positive 2x. But then negative 14 and positive 2, that's going to be negative 12x. All right, so that's what you get when you combine all four x terms. But then finally, we have the negative 2 and another negative 2. Those are like terms. So that will give us negative 4. So this is an expression for the perimeter. Okay, now we want an expression for the area. Well, area is length times width. Okay, so for the area, we're going to multiply. So we're going to do x minus 2 times 3x squared minus 7x. All right, you multiply. So how do you multiply a binomial times a binomial? This is when you do the distributive property twice. So first, I'm going to multiply everything by x. So if I do x times 3x squared, that will give me 3x to the third power. Okay, this is like x to the first power, so when you multiply, you're going to have 3. Now I'm going to do x times negative 7x. That will give me negative 7x squared. Now I need to go back and do the distributive property with the negative 2. Negative 2 times 3x squared is negative 6x squared. Negative 2 times negative 7x is positive 14x. All right, a negative times negative is a positive. Are there any like terms that need to be combined? Yes, we have the squared terms here. So negative 7x and negative 7x squared and negative 6x squared. Those need to be combined. So I will bring down the 3x to the third power. But then when you combine these, you get negative 13x squared. And then I will bring down the 14x. So this would be an expression for the area. Phoebe was asked to factor out the GCF of a polynomial. Her answer is this. Explain how you can see her answer is wrong. You don't need to know the question beforehand. You don't need to know the question that Phoebe was trying to answer. The reason why we know this is wrong is because if you look at what is left inside the parentheses after Phoebe pulled out what she thought was the greatest common factor, you see that there is still a common factor left. And that should never happen. If you correctly take out the GCF, if this is really the GCF, there won't be any common factors left behind. So the common factor I'm talking about is the x. See how both terms still have an x? So as far as answering the question, we could simply say both terms inside the parentheses still have an x. All right, in common. Okay, so if you factored out that common x, like forget the 5x squared for a second. I mean, the question is over. Like, that's the answer. Both terms inside still have an x in common. That's why we know her answer is wrong. So now I'm just expanding on that. Imagine if you factored out the GCF that's still here. You could take out an x, and then if you divide both terms by x, that leaves you with 3x squared plus 4. Okay, so you could factor this further and it would become this. Now, what we have, if we use her original guess at a GCF, the 5x squared is still sitting there. Okay, if you multiply these together, you end up with 5x to the third power times 3x squared plus 4. So basically, this is what she should have had for the answer. And more specifically, that means 5x to the third power is the actual GCF of the problem.